Hello, ngHouston. I'm super sorry we're getting started a little bit late today, but we're here and it's going to be a great show. And I'm very excited. Actually, my friend is back. Ilia, you were on once before, and I thought you did such a good job that I asked you to come back and come on the show again and teach us more cool stuff. And so I'm very excited to have you. And I'm also excited to have our panelists. So let's actually start introducing our panelists first, and then we'll circle back around to our special guest. Kevin, thank you for joining us today. Do you want to say hello and tell us where you're at, what you're working on?
Yeah, thanks for having me. I'm Kevin Schuhard. I'm coming at you from Denver, Colorado. And I work for a company called Breebug, and we're working on lots of exciting things. And right now I'm working for a company that has controls satellites in space. So it's a pretty interesting project.
That is very cool. That's very cool. And so this is your first time on ngHouston as a panelist, because the last time you were on ngHouston, you were actually one of our guests coming on with Brian, as we call him, B-Love.
Yeah.
Teaching us, what was it? You were teaching us schematics just a month or two ago. That was a really cool episode.
That's right, schematics. Yeah, they're really exciting. It's kind of a new thing, so it's fun to be on the front end of.
Yeah. So if you want to learn about schematics, go back a few episodes. But for right now, you get to an easy job today. All you have to do is heckle Ilia. So, but I'm glad to have you because I know you'll probably have some good questions and insights for us too. Okay, so Ilia, I have to ask you again. I know you've been on the show before, and this is not a new thing, but I love the pictures behind you. So for those of watching who have not seen your last episode, can you just give us a quick refresher on the art collection behind you? Because it's like you have like the coolest office.
Actually, this is my home. It's not my office. From time to time, obviously,
you have the coolest home.
Office, but yeah.
You have the coolest home slash office.
Thank you. So these pictures, there are a lot. I'm not sure if I'll be able to show all of them, but they are present. Most of them are presents to my grandfather. And yeah, basically, he passed away some time ago, so they're just mine, I guess. But yeah, it's a really beautiful collection, and most of them are from Bulgarian artists, and yeah, they're really cool. I mean, you should come to see them in person.
I really do love them. Nice. I think they're very cool, very cool. And speaking of Bulgaria, what was that shirt you were wearing today?
Yeah, so I'm one of the co-organizers of Angular Sofia. This is like the National Theater of Sofia. It's a very iconic building for our city. And yeah, these are our t-shirts that we made for our ng Christmas event. And basically what we did, even Sebastian was here. He actually gave the idea to create this online game and to pick winners from the game, so we can just give the t-shirts. So it was really cool. All of the people really enjoyed it, so we had a really nice Christmas party.
I love it, and I love Sebastian. Just a little bit of trivia for my friend. I actually see a couple of my friends in the chat, and so I think we're gonna have a lot of fun today. Just a little trivia for you guys who don't know Ilia. The first time I met Ilia, he was wearing a duck costume. A little onesie duck costume with Sebastian running around at Angular Connect, and it was and I didn't know who he was, but I knew he was really fun. Whoever it was, I was like, I have to meet that guy because he's a hoot, and definitely you are a lot of fun. Okay, thanks. So we should just jump right into it because I know a lot of us here, at least in the States. Well, last time you were here, actually, it was 1 o'clock in the morning your time, which was pretty awesome. But so we moved it earlier, so we should just jump right in and get started. You're going to teach us HTTP?
Yeah, so what I'm going to talk about is HTTP2 and kind of differences between HTTP and HTTP2. I'm going to mention HTTP3 as well, because it's right around the corner, I guess. And I'm also going to talk about protocol buffers and just stuff like that. I mean, I kind of find it boring now since I kind of dig into this stuff. So I hope that it's not going to be very boring for you guys.
I mean, I've used HTTP, but I haven't used protocol buffers. Is it going to be confusing? Is it going to be super simple? Is it going to be
my presentation is really basic, so I think that you understand everything. So Yeah.
Awesome. Awesome.
Okay, so what I'm about to do. Oh, first I wanted to say thank you that you changed the time, because before it was really hard for me because
Yeah, that's
just
why
like
we changed the
3
time, Ilia,
a.m.
for you.
Yeah, yeah, and I'm happy because there aren't so many panelists. So
Well,
it's
we
not
do
going
have a
to.
lot of people watching in the chat, so we will have we have 12 people watching now.
Oh, okay.
So yeah, so share your screen and teach us something cool.
Okay.
I'm
So
excited.
I'm about to share my screen. Hopefully you're about to see, like, do you see? Okay.
Yes.
Yep.
You see?
Okay, perfect. So what I did is that I created 2 applications in one folder. The first one is the server. Basically, it's a basic HTTP server, and the other one is a basic Angular project. So I'm going to start with the server. I'm just going to. So usually, like, we do our projects in TypeScript. So all of the backend is in TypeScript as well. And what I did here is basically that I used the HTTP2 module from Node.js, and I just create a simple server. So the first difference between HTTP2 and HTTP1 is that HTTP2 runs only encrypted. So if you want to run an HTTP2 server, you need to have certificates. So usually, like on the Node.js page, you can find how to generate self-signed certificates so you can run your server. And here I just create the server, and basically I created a small router. It pretty much mimics, let me just stop my email because it's jumping around. Sorry for the inception there. So yeah, I created this kind of very simple Express-like, I should say, module that pretty much gives me the possibility to create handlers for certain endpoints, just like this one for the users, and gives me the possibility to use middleware, just like Express does. And the difference is, like, first I want to show the configuration for this kind of Express-like module. Of course, we have the possibility to serve static assets, even though it's not very optimal to serve static assets from Node.js, but this is another topic. But what is interesting here is that we have this, like, push configuration. So the main difference between HTTP1 and HTTP2 is that with HTTP1, we have, when we are making a request, we have to open a TCP connection. And whenever, like, we are dispatching requests from, for example, the browser, we have a certain limit of TCP connections that we can open. And the limit is, I think, around 6. So pretty much this is one of the reasons why we have to bundle our applications into one big piece of, or at least a few big pieces of code, and ship them to the user. So we don't have to make so many requests. But with HTTP2, we have a single TCP connection open, and we can basically do multiplexing on over this TCP connection. That means that it's not even worth bundling the application anymore. You can, of course, minimize it, but you can keep it, like, separate. Just because you don't have to open, you don't have this limit of 6 TCP connections. You basically have one TCP connection that you do multiplexing on. So pretty much, they say, like, today's best practices are not even like best practices, even more if you're using HTTP2. But anyways, the thing that we are looking now is this push configuration. And with the push configuration, I can say that when I get a request for this, like, URL, which is like the default one, I can just push even before the browser actually requested some stuff. And what actually happens is that this stuff gets sent to the browser, and they get cached there. So whenever, like, the browser decides that it needs those assets and creates the requests, the request for them, it basically just gets them out of the cache. So it's pretty fast. And yeah, I'm just going to quickly show you what I do. So in this connect, I'm just listening to on the HTTP2 server for the new streams that are coming. And whenever a new stream is opened, I pretty much check. I'm using what Express is using for generating or just generating regex for certain paths, and I just match the certain path that the request is for. And pretty much I'm just sending, I'm just checking if there is like push data that I want to push to the server. And yeah, basically I'm just handling the request as normal from there on. So if we go, for example, on this page, which is like a random newspaper, I didn't want to show the name, so I hid it. We can actually see all the requests that are done. I think Chrome is kind of like not showing what I wanted to show right now because the waterfall is kind of gone. So I guess I'll have to refresh the page so we can see like this thing called the waterfall. I think most of you know what that is. But basically, just because we have this limit of 6 connections, of 6 connections per origin, you can see how, for example, this request is queued for 527 milliseconds, and this one is even more. So with HTTP2, if I open our website, you can actually see that we don't have this big waterfall. We basically have all the assets kind of like pushed before they were even requested. For example, if I go a little bit down, let me just see, there is like this image somewhere that you can actually see. Yeah, for example, this, like the main bundle here, the main Angular bundle, it's not even like it's kind of like requested from the server, but it's actually already inside the memory of the browser, so it's just read from the memory. So do you kind of get what this HTTP2 push does, or should I explain it more? It's kind of hard.
I think this is okay. Kevin, what do you think?
Yeah.
Yeah, this is making sense.
Yeah, so pretty much I'm just pushing assets even before they're requested, right? So this is one of the reasons why HTTP2 is very nice. Just because for different paths on your website, you can configure what assets should be pushed even before they're requested, and this basically gives you speed. Okay, so enough with this. Like the interesting part actually is, let's go to the index.ts, that we have this like subscribe handler. So usually when we're using...
Sorry, we have one person who said it was big enough and one person who said they wanted a little bit bigger. But I think it's a bit small. Can you just zoom that text like one little bit so we can there?
Yeah.
Thank you.
Is it okay now?
Yeah, you can. Yeah. Okay. Perfect. Okay, I'm going back on mute. Yeah. Thank you.
Okay, no problem. So the interesting part is that we have this like subscribe handler. And what it actually does, if we go to the custom mode that I created, is basically it listens for methods that are GET requests, and basically it automatically creates a subscription for this asset. And what I mean by subscription is that we are kind of like able to do something that a lot of students, because I teach in university, ask me. So whenever like they see Angular and RxJS for the first time, they're kind of like, okay, so I kind of make a GET request for this endpoint for this endpoint, and I'm expecting the data. But does that mean that whenever like the data changes on the backend, I'll receive the update as well? And this is the sad part, because I have to tell them not actually, because when we're talking about observables with the HTTP clients, you just get one thing and that's it, right? But with the module that I created, you actually have a live subscription. And just because we have this like single TCP connection, we can actually keep some streams, because we can we are actually communicating via streams, right? I mean, it's not like request response. It's basically we can have multiple streams over this TCP connection that are open, and we don't even have to close them, just because if they're not sending data, basically the TCP connection is free for use, right? So this is what actually the this subscribe method allows me to do. Okay, just I want to. It's kind of hard for me. It's like my first time presenting on
You're doing
Hangouts,
awesome.
so,
You're totally fine. I am on podcasts all the time, and last time I was presenting on Angular Air, I got all flustered because everybody was looking at me. It's hard. You're fine. You're fine.
Yeah. Okay. So yeah, this is like the subscribe. Pretty much, we can check the post method. What the post method does actually is that it gets like the data from the body that we send, and it simulates some asynchronous operation. And whenever this asynchronous operation is processed, basically I'm just simulating here that we are putting some data inside the database, even though on the demo the database is inside my memory. So pretty much I just have this array. And internally, I'm having this like method that I call. It's called the notifier, and whenever I call it, basically all the subscriptions that are connected for this route, this one here, get called. And for example, we can see that when I type an H here and a name and an H here, whenever I click the button, after some time, because I have this delay, this thing shows like here. So pretty much we have the live data. And inside this tab, we have it as well, because both of the tabs are kind of like subscribed to this endpoint. So nothing very special here, I guess. I guess I'll just go to the front end so we can see how we're handling things there. So what I've created is this called fetch client module. Pretty much what we have inside is that we have this service. It's called the fetch client. It's not the HTTP client, just because I'm providing a different backend. So usually when you're using the HTTP client, defaultly you're using the XHR I think handler backend or something like that. Basically, they're doing XHR HTTP requests, but I just provide this custom-made backend. It's called Fetch, and you guessed it, it uses Fetch inside. So I'm not sure, you're probably familiar with Fetch, right? It's not something new. Pretty much, it's a better API to make requests, asynchronous requests to the server. And what is cool about it, that is it uses promises. So basically what I do here is I just create a HTTP requests, and then I get the response, and depending on the response, I just handle it in some way, right? And I also keep all the HTTP client methods. So pretty much what I change is only the backend, and inside the backend we only have this handle methods. And whenever we make a request from our application, basically this is the method that gets called. So inside here, as I said, when we do the get request or the post request for a certain endpoint, we create our fetch request. And I'm using from RxJS this thing called observable from. So I can create an asynchronous stream from this promise. And basically, depending on the response headers, I do certain things. So I'm just going to focus now on the part where we are actually handling just JSON responses. And then I'm going to, when we finish with this, I'm just going to dig into what protocol buffers are and why I actually decided to put them inside this demo. So whenever like JSON request comes, basically I call this method. It's called the get response processor. I have this method just because I have two types of handlers. One is for JSON and one is for protocol buffers. So inside here, what I actually do is just because I'm using the fetch request, I can actually use the browser stream API. So what the browser stream is, if we go here, we can actually see this diagram. It explains how the fetch actually works underneath and how it uses the browser streams. Browser streams are something that are still not in all major browsers, but they're slowly getting into them. So we see here, like we have our server, and our server is sending some data. And the cool thing is that we can actually process the data chunk by chunk, and we can actually output the data in the same way. So we don't have to wait for the whole data to get downloaded to the browser to kind of like do some certain modifications and present it to the user. What we actually can do is create this kind of like, we can think of them like RxJS operators that kind of like modify the data. And inside our subscription, we can kind of output what the result is. So this is like the browser stream standard. And here, if you go on this page, you can see like there's this link that they actually show you demos. And this is a really like simple demo, and you can actually kind of associate it with RxJS. So what they do here is that basically they get the response body from the fetch request, and they pipe it through different kind of operators. So what they do is kind of like that they code the stream. They split the stream to on new lines. Then parse it to JSON, and basically they kind of transform the elements to a table row, and they append it to the table that is presented on the HTML. So it pretty much, it does look like RxJS, right? It's not very different. Opinions?
Sorry, I was answering you, but I was on mute.
Oh, okay. It's kind of like strange.
So basically, you can do this. You don't actually have to have RxJS to have this functionality.
No, this is baked inside the browsers. Not all of them. If you want to see in which ones, you can go on this website, Can I Use, and basically you can see which browser supports the Streams API. But it will be in all major browsers, hopefully, and I hope soon. But in Chrome, it's definitely working.
What about for HTTP2? Like, what's the adoption on that? Do I need a specific browser, or is it pretty well adopted?
So HTTP2 is supported in all major browsers. What is cool about the HTTP2 server is that it's very easy for you to kind of fall back to HTTP1 if the browser does not support HTTP2. So basically, there is no pain to kind of transition to HTTP2. You can only gain from this. And there is no pain because actually the semantics of the whole HTTP2 is just like the one in HTTP1, with small changes, of course.
Right.
But
nice.
It won't break anything. Yeah, it's something that I think everyone should be using nowadays. But fetch, the fetch API is not, you can use it with HTTP1, you can use it with HTTP2, it doesn't matter. The only thing that is different is for example, transform streams, because they don't work in all major browsers. Okay, so basically what I'm doing here in my processor, I'm getting the reader, and basically the reader provides me to kind of start to start reading from my stream that I opened, and to process the data on chunks. So here I just create an observable, and in this observable I call the read method from this reader, and I create this function called the read handler. I just want to say that the code is not very good looking, just because I didn't have time to kind of refactor the code more, but I think that it's okay to look at. So I create this read handler, and whenever like there is some data, I kind of kind of like create this this content thing that I keep all the data inside, and I try to see if I can actually extract, for example, a JSON object from it. And if I cannot extract, I just continue forward with reading the stream, so I can collect enough data. And when I collect enough data inside this content, basically what I do is that I process this data and I emit it to the observable. So you can kind of understand what is happening. If I'm kind of like streaming a lot of JSON objects, at certain point I might not have the whole JSON object received, right? Because I'm kind of like collecting all the small chunks of data. And what I'm doing here is basically I'm making sure that I have enough chunks collected so I can actually parse the JSON and push it to the stream back to the client, okay? Basically what construct response does is it just constructs a response just like the one that we receive from that we get from the HTTP client. And probably the more interesting part is this processor that I am actually using. The JSON processor is really simple. If I'm kind of like streaming a lot of JSON structures, I use as a delimiter the new line, because actually when we are streaming JSON objects, the new line is, we cannot have a new line inside those. It's just not supported to have new lines inside the JSON objects. So this thing is called JSON streaming. You can, this demo will be uploaded when I finish the talk on my GitHub account, so everybody can look at it. So this, you can actually check this stream, check this link a little bit later to kind of read more about JSON streaming. So what I do here is basically I check to see if I'm kind of like iterating over the whole data that I've collected, and I'm kind of parsing all the different objects that I get inside. And I just emit whenever I have an object. Any questions on this? It's kind of like straightforward, I guess. I don't know.
It's very straightforward.
Yeah.
Okay.
Good.
Okay. So I guess this is all like for the JSON processing. Pretty much it works the same way as the protocol buffer one. But why is it not good? Like what is the difference between using JSON structures and using protocol buffers? Well, JSON, first of all, why are we using JSON nowadays? One other difference between, sorry, I don't know, my throat is kind of bad right now.
It's because you're on YouTube. It's a thing.
Yeah, probably.
Okay.
So HTTP1 is a text-based protocol, and pretty much when we're using it, we are always working with text. And JSON is pretty okay if we're, I mean, it's the best thing actually when we are working with JavaScript applications, but it's not the best thing when we are actually not using a text protocol. HTTP2 is a binary protocol, and that means that we can use other formats like protocol buffers that are binary and much more optimal than JSON. So the hardest thing with JSON is that it's not strongly typed, and it's very, for example, when we're doing JSON parse, it's taking a lot of time to kind of parse the data. So it's taking a lot of time to encode the data on the server and to parse it on the front end, right? So with protocol buffers, this is not the case. They're really cool. They're actually kind of they're built by Google, and basically what we have, this is like a simple structure of a protocol buffer. We can define different types of messages, and each property of this message can have a type. So we can define, for example, that this is going to be a string and this is going to be an integer, and we can actually use customly create messages types inside our different properties as well. And what we actually do here is that we kind of give them numbers. These are kind of their unique IDs. And yeah, so protocol buffers are strongly typed. This is really cool. And one other thing that is really cool is that they are language neutral and platform neutral. That means that they work on Python, they work on Go, they work on every language, and we don't have like this barrier that we usually have with when we're doing JSON to communicate between our front-end application and the back-end application. By barrier, I mean that we have to kind of like use these transformers that kind of like get, for example, gets the JSON that get the Python object, and they kind of have to convert it to this JSON structure and then send it over the wire. Basically, we can just parse it as a protocol buffer and just send it over the wire. So yeah, this is why I decided to include protocol buffers here, just because HTTP2 is a binary protocol, and whenever we have a binary protocol, there are much better ways to send the data to the clients. And one other thing that it's cool, of course, is that you can use protocol buffers with, for example, mobile applications as well. So they're really cool. Okay, so this is why we actually have the other type. Here we have the protocol buffer processor. Okay, let me just go back to the backend really quick to show you how my protocol buffer files look like. So inside the server, I have this folder. It's called Protos, and inside Protos, I have this user proto. It's basically the user message structure. So inside, oh yeah, another cool thing about protocol buffers is that they're versioned. So we can actually keep track of the different versions that we create, and it's really kind of easy to kind of maintain. So here, basically, I have a user message, and the user message has a name, and this name is, of course, going to be a string, and the age is going to be a floating point number. And inside here, let me just go to the place where I'm actually sending the data as a protocol buffer. So yeah, what I created here is this called protocol buffer parser. It's basically a wrapper, and it is here inside parsers. So what I'm using is called protobuf.js, just a library that you can use either on the backend or the front end. So now we're going to just look at the backend side. Here, yeah. So basically, what I'm doing here is that I create these two types of parsers. One is the receiver. Basically, what the receiver does is that whenever I get some data from, for example, the front end on the back end, I need to kind of decode this data. So this is pretty much what I'm doing here. I just get the data from the stream, and then I just look up for the certain type of message that I have, depending on what I given to this function. So in this example, we're only using the users proto. So pretty much I get the proto message, which is this one here that I showed, and I kind of decode. It's straight. So when in data, I pretty much do the same thing. I get the proto message and verify that the data matches the types that I have inside the proto. So this verification checks to see if the provided values are, for example, string and a floating point number. Of course, I didn't have to do that, but sorry about that. And then I just construct my message from this object that I received, that I created. Then I just say that I want this protocol buffer to be kind of delimited. This means that whenever I'm sending a protocol buffer message to the front end, on every protocol message on the front, I will actually have the size, and depending on this size, I will know if I have to process the chunk or not on the front end. So this is pretty useful. And then I just write to the stream this message that I actually created. So pretty much this is all. It's not. This is for demo purposes. Actually, this set timeout. We actually don't need it here. I guess I left some stuff because
use set timeouts in my code all the time, Ilia.
But no, I mean, just because it's kind of strange, because I'm here I'm writing the buffer to the backend, to the front end, and then I'm sending it again. So this is because I just wanted to test something, and I kind of forgot to leave it, to delete it.
I know. I'm just giving you a hard time.
Yeah, but I use set timeouts when. Actually, I don't use set timeouts so often because I use RxJS intervals.
I use set timeouts all the time. In production.
Don't use when you're using RxJS. Just use intervals. It's much better. It's much more beautiful, at least for me. Okay, so we saw what's happening basically on the backend. Pretty much when we are actually sending the data is right here. I get from the protocol buffer parser, I get the sender, and then basically I just send the data that I want the front end to receive, which are my users. And on the front end, basically, if I go to my backend, what I do here, a little bit, just a second. I just need to find the part where we actually load so it's this thing get decoder. So depending on the type that I receive, this is actually depending on the headers that the server sends, I can actually parse the response either in JSON or either as a protocol buffer. So whenever I receive in the headers that I want to parse the response as a protocol buffer, what I do is that I send a request using the protobuf.js library to the server, and basically this load request, what it does is that it actually fetches the same file that I was using on the server, this user proto file here, and what it does, it actually creates this like root for my message, pretty much the same thing that we actually did on the backend, and depending on this route, I kind of like process the message. So let me just go.
Can you tell us again? And I know it's my fault because I told you that we have to like try to keep it under an hour because we're on our lunch breaks now that we're earlier. But you're also covering a lot really quickly. So can you tell us and just for me tell us again the prototype buffer? It's faster. Like the difference between.
Okay, so the difference is that first is strongly typed, so we kind of know that this thing, the property that we're sending is either a string or a floating point number or whatever. And the second thing is that it's actually binary. Okay.
So we would want to use this instead of JSON.
So whenever you have the option, if you're using HTTP2, you can use protocol buffers because HTTP2 is a binary protocol, and it's going to run much faster than using JSON. Because JSON parsing and JSON JSON parsing is really slow operation. I mean, encoding and decoding of JSON is kind of slow. I've seen even people using asynchronous JSON parsers.
So this is really just another optimization that's afforded when you're taking advantage of HTTP2, right?
Yeah, this is another optimization that you can actually use when you're using HTTP2. It's not necessary to do it, but if you really want, if you're setting really big responses, JSON, JavaScript object responses or whatever object responses, it's much faster for encoding and decoding those responses.
Gotcha.
So we have Martin Chaos Monster in the chat who was late. That's okay, because we're glad he's here. We love Chaos Monster. And he actually had a question that I was thinking about earlier because I was watching you and I was wondering, because this kind of functionality, like you could also do this with WebSockets, or I would probably use GraphQL for something like this. But can you tell us if there's any advantage of HTTP2 over WebSockets?
So yeah, WebSockets, WebSockets are an upgrade over HTTP1.
Mm-hmm.
So pretty much you cannot use WebSockets with HTTP2, but you actually don't need WebSockets with HTTP2 just because HTTP2 is like a WebSocket. And what is cool about HTTP2 is the difference between WebSockets and HTTP2 is whenever you are actually opening a new tab on your browser, each time you open a new tab, a new WebSocket is kind of opened. With HTTP2 is not the same. Basically, HTTP2 is not stateless as HTTP1, and this means that a single TCP connection is open for all of your tabs. This means that as many tabs as I open, I have this single HTTP connection that is basically listening to the stream that I opened, and whenever I push something, all the tabs get it. It's one stream, okay? It's one TCP connection.
That makes sense.
Yeah, so whenever you're using, first with WebSockets, there are a lot of problems, for example, with firewalls, with proxies. So I kind of don't like WebSockets, even though this was kind of the only, not the only way, but the most easiest way to do real-time communication. For example, even Facebook, they're not using WebSockets. They're also really hard to scale.
I feel like WebSockets is like REST API. Like when it first came around, it was very, very, very cool. But it's been a while, and so the technology keeps on moving.
Yeah. Basically, WebSockets
was like pretty bomb.
Yeah, definitely. But there are a lot of disadvantages with WebSockets. And basically, I would prefer using HTTP2. This is what I'm doing here, and what I'm showing is actually that something that we used to do before when we didn't have WebSockets. For example, before what we had to do was called, for example, long polling. And what long polling was that we actually send a request to the server and we wait for a certain time. And if something happens on the server, it basically sends the response back to us. And then we send another request, right? Pretty much, I'm doing the same thing here. Instead of just opening and closing the new connections, I just send a request and I keep the connection open. And whenever like there is a change on the backend, I just push the data back to the client. And if the client also wants to push something, it can do that as well, just because we're using HTTP2 and we have bidirectional streams.
So HTTP1 would not allow you to keep that open, and HTTP2.
No, you can definitely keep a connection open with HTTP1, but that means that you're using one of the 6 TCP connections that the browser allows you to use, right? So, yeah, these are the main differences.
Ganga wants to know if WebSockets uses observables. Do you know?
WebSockets, they don't use observables, but you can use observables with WebSockets. Pretty much, if you're using RxJS, if you import from RxJS/WebSocket, the observable constructor code, I think it was from WebSocket or something like that, it can actually create a stream. It actually creates a subject from this WebSocket, and basically you communicate through this subject. So pretty much you have the stream that you want. Yeah.
But what you're saying with this HTTP2, you ideally probably wouldn't use WebSockets anymore, because this is now.
Yeah, definitely. You don't have to use.
So 2017, y'all.
Sorry?
I was making a joke, Ilia.
Oh,
it's
okay.
like, yeah, that's so last year. We don't do that anymore.
But definitely, even now, I'm not sure how of you know, but they even announced HTTP 3 just because HTTP 2 doesn't solve certain problems. With HTTP 1, we have this thing called head-of-line blocking. So basically, if we have a very heavy request, it can block other requests that are kind of faster. And all the faster requests have to wait for this very slow request to finish. But with HTTP2, just because we have multiplexing, this doesn't happen, right?
Right.
But when you go a little bit down on the TCP level, what does TCP actually do? It checks for each chunk if it was received, right? So basically, we still have this kind of head-of-line blocking, but it's on the TCP level. So what actually they decided to do is to move HTTP over UDP. Because when you're actually using UDPs, when you're using UDP, you don't have to check if this package was successfully delivered. And yeah, basically this is what HTTP 3 is going to do. It's basically going to send messages over UDP, and it's going to be even faster. I mean, it's going to be faster on lower connectivity networks. For example, if you're on a train and traveling through a tunnel or something like that, you'll be, I mean, it will be kind of like faster to send messages there when you don't have good connection.
That's well, we have a lot of people who are doing mobile development, and that's very important. And I think it's getting more important everywhere for all over the world. This is so great. Okay, so I know you were going through this demo and you were covering a lot of stuff, and we kind of interrupted you and asked you questions.
No problem.
Did you finish it? Did we or are you? Or
yeah,
do you want to
so
finish?
pretty much this is what my demo was. You can actually like see whenever you're typing something and you send it to the server, it actually pops out to both browsers, right? So this is like the kind of real-time communication that I wanted to show. So pretty much what I wanted to show here was the protocol buffers, the HTTP2, and yeah, so I kind of covered it, I guess.
So this whole thing, sorry, they were talking to me in the chat.
No problem.
Okay, so this whole demo is on GitHub.
So I'll just, I have a repository, but currently it's private. I'm just going to kind of make it public. Okay. And usually I put my demos here on my GitHub account. I have this repository called slides, and here I put all the slides from my talks and stuff like that. So I'm going to put a link here.
That's such a good idea. So, yeah. I need to do that. I had somebody ask me for slides. Actually, Andre just asked me for slides this morning, and I was like, oh, I need to put those up somewhere. And so I should just.
Yeah, I use GitHub because I am very busy. I don't have time to maintain a blog and stuff. So I just do the normal procedure. I just push it to GitHub. So it's very, very easy.
Okay, so also, so everybody, you can find his GitHub. It's Ilia, and you can see the spelling of his last name right under the video. And yes, Martin, I will also tweet it.
Just one quick thing that I forgot. For people who are interested, there is like this library. It's called gRPC. And what gRPC does, it actually uses protocol buffers. But inside these protocol buffers, we can actually create services as well. So pretty much what I've created on the backend using Node.js, this library can generate all the code for you only from your protocol buffers. So basically, these messages, these proto files that I showed, it kind of reads them and it generates your API from them. So you don't have to even write code. It's really cool.
Nice. So you can create like a models file. And let that generate it all out.
Yeah, and it also supports this kind of subscriptions that I showed. So internally, it uses HTTP2, and it also uses protocol buffers. It's really nice.
Very nice.
Okay, so I guess I'm sure that I forgot something, but how should? Okay.
Take off your. There you go.
I don't know. I'm kind of.
That was awesome. You covered a lot in a very quick amount of time. And so everybody is going to have to go back to the beginning and watch it on slow because there was a lot there. But I really like this because the technology keeps on moving. And sometimes it's kind of easy to just keep doing what we were doing because that's what we know and we know that it works. But then if there's something new out there that's a little bit faster or a little bit easier or better to use, we have to kind of try to keep up with all that stuff. So I really appreciate you coming on and showing us stuff because I learned some new stuff today that I did not know. So that's very cool.
That was the idea. Usually this is how I do things. I kind of like present certain things, and if people kind of get interested, they start digging around them. So it's pretty cool.
I do like it. I like it. Martin wants to know if there are schematics for HTTP 2.
Schematics? You mean for Angular? No,
yeah.
No. I think that for Angular it doesn't support fetch. It doesn't support fetch, and HTTP2 is just a protocol. I mean, it's not connected with Angular in any way. It's just
because
connected
Angular
to the
actually has the HTTP client, which uses HTTP2, I believe. No.
No. I mean, it depends on what
brand
the
new then.
No.
The Angular team doesn't even have this.
They're separate. They're separate. Like this is HTTP is the protocol.
I gotcha.
Yeah, so pretty much they're separate. They're not connected in any way. For example, if the server supports HTTP2, the browser will out of the box use HTTP2. So Angular will use HTTP2.
Yeah, I think there's a disconnect between the client code and then the browser. So it's like the client code doesn't necessarily have the choice or the control over that, right?
Yeah, it's just abstractions, but
yep.
It's
because Angular is client, but what you showed us today was like how to set up the actual backend server to push everything out, which was very cool.
Mm-hmm. Yep.
I love it. I love it. Okay, I think we got to wrap it up because we all have to get back to work. It's only noon here in Texas, and we got a lot more to do today. But Ilia, this was awesome. Thank you very much for coming on and showing this to us. And I am going to make your GitHub public, and then I'll tweet out a link. And you should hopefully come back and join us more often now that we're earlier in the day and it's not the middle of the night for you anymore. We always love having you on. You can come back and teach us cool stuff. You can come and just hang out with us as a panelist anytime. Sure. You're always welcome. Thank you so much. And thank you, Kevin, for sitting in with us.
Yeah, thanks for having me.
Thank you, guys.
Great talk.
And one more thank you for all of my friends in the chat. Thank you for coming in and joining us, and always, reach out to us. Ilia went pretty quick, but Ilia, are your Twitter DMs open if they have questions for you, follow-up questions?
Yeah. If you have questions, you can message me, or you can put, for example, issues on this repository that I'm going to open source it. Whatever way you can contact me, no problem.
Awesome. Thank you so much. All right, we'll see y'all next week. Oh, by the way, Otto is coming next week from Auth0. And we're going to have a special Valentine episode. He's doing secret chat messages for your Valentine. So if you want to learn about authentication, security with our friend from Auth0, tune in next week at the same time, same bat channel. Okay, thanks everyone.
Bye.
Bye, everyone.